Okay, we're going to do a quick recap. We're still talking about rational functions, specifically the vertical asymptotes and wholes, and we have connected them to limits. So if I have a limit that is approaching a whole from the left or the right, then that is going to, the answer to that, the limit is going to be some number. Okay, so I have an infinite amount of possibilities there. If I have a limit that is approaching an asymptote from the left and the right, my only options are negative infinity and infinity, right? Well, good on that. All right, so then we practiced finding the wholes in the vertical asymptotes again, and then we did that here and got our limits, and we have the function, not the graph, and I had a limit that was approaching the vertical asymptote, so I had to do a sign chart to know if I was going to positive or negative infinity. When the limit was approaching a whole, we have the x value for the whole, and then the limit is just whatever the y value of that whole is. And the question was asked yesterday by some people, like, how do we know to go to 2? Because it says so right here. And we got to make sure we read the questions, okay? So not really a stupid question, because sometimes you do read the question, and then you just forget why you were supposed to know something. It's because it was up there in the question. All right, so the first thing we want to do on C to get our limits here is we need to see if we can cancel anything out. Okay, so I can cancel this out with one of those. And that's all I can cancel, so it looks like I have a whole x equals 2. Then I look for vertical asymptotes. And I have 2 things down here, so I have a vertical asymptote at x equals 2 and one at x equals 1. Now, can I have a whole and a vertical asymptote at the same spot? No. Which one always wins? Very good. So we just mark that guy out. Okay. Do you have to write it down, then mark it out? No. But chances are pretty good you'll already have it written down just because you're going through a process. And that's totally fine to go through that. Then I'm also going to need my, well, I don't know. We'll figure out if I need my zeros or not. So let's write in our little stems here. The limit as x approaches 2 from the left of h of x. And remember to make sure that you call it h of x if it's h of x. Don't call everything f of x. And then the limit as x approaches 2 from the right of h of x. Okay. Now, what is happening in this function at 2? X is a vertical asymptote. So since it's a vertical asymptote, my only options here are infinity and negative infinity. So I got a 50-50 shot, but we don't want to guess, right? We want to know how to do it for real. So since it is infinity or negative infinity, I'm going to have a number line. On the number line, we always put our vertical asymptotes, and we put our zeros. So I do need my zeros. Like this here, I didn't necessarily even need it. But my 0 is at x equals 4. So I've got to put those 3 numbers on here. 1, 2, and 4. And remember, I don't have to do the entire sign chart. I'm not solving an inequality. I am just trying to figure out what's happening really close to 2. And so this is the only part I really care about. But I need the other numbers on there so that I know that when I pick things on either side, I don't go too far. Because if I go too far, it may change my answer, and we don't want that to happen. All right, so then to the left of 2, I'm going to pick 1.5. See, if that wasn't there, I might pick 1, and that would be a problem, or 0. So 1.5. 1.5 minus 4 is negative. 1.5 minus 2 is negative. 1.5 minus 1 is positive. So that is positive overall. Which means to the left of this, we're going to positive infinity. Okay, that makes sense? Then on this side, between 2 and 4, I could pick 3. 3 minus 4 is negative. 3 minus 2 is positive. 3 minus 1 is positive. This is negative overall, which means the function is going to negative infinity. Okay? What questions do we have? Ask me a question. Ask me a question. Oh, it was. Somebody's phone was vibrating. It's fine. Yes, yes. Okay, that's a good question. So how do I know to do this and not this? Well, if I had done this here, it really wouldn't have done me any good, because if I'm trying to look around my asymptotes, at 2 on this one, I have a hole. So when I have an asymptote, and these are my only 2 options, right? My only options are negative infinity, infinity. I'm going to do my number lines just for the positive and negative. If I'm approaching a hole, like we were here, just use a picture. So since I'm approaching a hole from the left and a hole from the right, my limit is a value. So as I'm approaching one from the left and one from the right, the limit is the y value of that hole. So basically you have to identify, okay, I want the limit as x approaches 2. What is happening on my graph at 2? If it is a vertical asymptote, you do a sign chart. If it is a hole, you just find the y value. Okay, does that help? Good question. What else you got? We good so far? All right, so I'm just going to forewarn you, you're not going to love the rest of it because it requires you, although I'm going to walk you through it, it requires you to create something of your own. And I know from many years of experience, y'all don't like doing that because you just feel like you don't want to write anything down unless you know that you're right. And I get that, but you have to learn to kind of get through that. So let's look at what this says. It says, write an equation of a rational function with the following limit properties. Okay, so the actual wording is very important here. Write an equation of a rational function. It doesn't say write the equation. If I said write the equation, that would mean there is one answer, and if you don't do it exactly like this, you're wrong. Write an equation. We don't have enough information to know specifically. There's basically an infinite amount of answers here. But we need to write something that would fit this information, okay? And would you have to write this stuff from scratch on the actual AP exam? No, but you would be given this stuff, and then you would have some that you'd have to match up. So if you can create some on your own, that means you actually understand how it all works. With me, it's just kind of making you think a little harder at it. Okay, so let's look at how this works. So it's really not that bad. It's just that some of you just, like, you're paralyzed with fear. You don't want to write anything because there's not like one answer or something. All right, so I've got the limit as x approaches 3 from the left and the right, and I get 5 both times. Okay? So just by knowing that information, that tells me that my graph has a what? A hole. Okay? It has a hole, and what is the x value of the hole? 3, and what is the y value? 5. Okay? See how much we know already? And then the limit as x approaches 1 from both sides is negative and positive infinity. So what does this tell me I have? Vertical asymptote at 1. X equals 1. Good. So then I have a vertical asymptote at x equals 1. Okay? So that's knowing some information. Now we're going to take that information and write an equation. And again, there's really an infinite amount of answers, but there's no reason to go crazy and get super creative. Like, let's just do some basic stuff here. So I know that this is named f of x, and I know it's a rational function, so I have a fraction. Okay? So let's start with part of the hole here. If I have a hole in the graph, that means I was able to cancel out factors that looked identical. Right? So they both had an x in them. If the x value of the hole is 3, these factors would be x what? Minus 3. Good. So would you agree if you saw that in there, we'd be able to cancel that out? We know we have a hole at 3. Yes? Okay, so that's part of it. Then the next thing is I have a vertical asymptote at 1, which means I have a factor in the denominator that's not going to get canceled out. That would be x what? Minus 1. Okay? So far, we have taken care of this and this, the 3 and the 1. What we haven't really addressed yet is if this is really the behavior on either side of the asymptote. Because for all we know, it might go the opposite way, or maybe they go the same way, but at least we know there's an asymptote there. So we're going to do a sign chart, but it's way less formal than the rest, at 1, to see with what we put in there, what would happen. And remember that you get to do this after you cancel these out. So we're just going to pretend like they're not, we're not going to actually cancel them out because we want them in there. But if these were canceled out and then I did my sign chart, if I substitute in something less than 1, like 0, that would give me 1 over negative 1, so that would be negative, which means it would go to negative infinity. And then if I substituted in something greater than 1, like 2, that would give me 1 over 2 minus 1, which is a positive 1, which means this side would go to infinity. Does that make sense? I'm coming up with that. And does this match what this says up here? Yes, then I'm good. So I don't have to flip anything over or whatever. So I'm good with that. The one thing we haven't addressed is this y value here. Because not only do I know where the x value is for this whole, but I also know the y value. So that means I need, after I cancel these out, again, pretend like they're not there, when I substitute in 3, my answer has to be 5. So right now, if I cancel these out, I substitute in a 3. 3 minus 1 is 2, right? So I need a number up here that I can divide by 2 and get 5. What would that number be? 10. I put a 10 here. That doesn't affect which direction these go, and I'm done. Okay? What questions do you have? Okay, now we could have made it more complicated. Like, for all we know, this is x minus 3 squared over x minus 3 squared. Or, or this could even be x minus 1 squared. Like, we don't necessarily know when we're building that, and maybe the coefficients are something different in the real equation, but this satisfies all of this stuff up here. We good? And we're just building it a piece at a time. You don't read it and then go, oh, I know what the equation is. Like, nobody, unless they're just like a savant, is going to do that. You have to build it a piece at a time. All right, let's try this next one then. We've got a limit as x approaches negative 2, and that equals 4. So that tells me I have a whole. What's the x value? Negative 2, and the y value? 4. Okay. Then I have the limit as x is approaching negative 1, going to the infinities, which means I have a vertical asymptote at x equals negative 1. Everybody with me so far? Just got that information from the limits. All right. So then my function, this one is f of x, and it's irrational, so here's my fraction. Let's start with the x value of the whole. That would mean I have matching factors. That would be x what? Plus 2, yes. And if those cancel out, then I get a whole at negative 2, x value of negative 2. You totally don't need a marker in your hand while you are doing this because you're totally not paying attention. All right, and then vertical asymptote, that would mean in the denominator I have x what? Plus 1. Okay. All right, so now I got it. So I've taken care of this and this. I got to make sure that these things are really happening here. So I'm going to do a little sign chart with the negative 1. And I get to do this after these are canceled out, so I'm just ignoring those. To the left of negative 1, I can put negative 2. So I'd have basically 1 positive over negative 2 minus 1 makes that negative, which means it goes like this. If I substitute in something greater than negative 1, like 0, I'd have 0 plus 1, which is positive, and it goes like this. Okay? So is that what this says here? Yes, exactly. So what I can't, like, let's say this was positive and this was negative, so these are really just opposite. Then I could just put a negative sign in front of it, and that's what reflects it across the x-axis. But it's really only reflecting one of them, and if they're both supposed to come up like this, when you have a sign chart and the sign doesn't change, that's because the factor, that factor is squared. Like it bounces and it stays positive or something like that. Or it stays positive on either side of this. So yes, I would need to, well, that has to be to an even exponent, but squared, again, we don't have to go crazy. We can put it to the 12th power if we wanted, but squared is fine. All right, so then now that that's squared, when I do that, this is positive no matter what I put in, and it's going to go to positive, positive. Okay? We're okay with that? All right. So I've taken care of that. I've taken care of this. I need to take care of this part right here now. So after these are canceled out, when I substitute in a -2, I need my answer to be 4. So if I substitute in a -2 plus 1 is a -1. When I square it, what does it become? +1. So I need a number that divides by 1 to give me 4. 4. Good job. And then you're done. Okay. Now again, I know that some of you are like, hey, I get that. And others of you are like, I would never, even though you could, I know what you tell yourself. I would never be able to create an equation like that myself, which is not true, but I know what you tell yourself. Remember, I am going to ask you on the assignment to try and create some of these because I want you to try and not freak out and not let your brain shut down. But I'm not going to make you do that on the test. What this would be is you would be given this information and then you would have multiple choice of a bunch of different equations and you have to know how to figure out which one it is. And if you can build one accurately, then you understand that. Okay? What questions we got? If it was reflected, so let's say we did all this, and it looks like this, but this was really supposed to be negative, negative. You would just put a negative sign out front, and the negative just reflects the whole thing. Good question. What else you got? Okay, so this next one, we are going to do these together. Like I said, some of these are on your worksheet because I want you to try. I'm 99% sure I didn't ask you to actually do this on the worksheet because I know better. This says, sketch a picture of a rational function that has the following properties. So sketch a picture of a rational function that has the following properties. So not the picture, because we don't really have enough information to know everything about it, but we can get this stuff on there. All right. So it says, let's see, we're going to 1 and 4, so let's just do 1, 2, 3, 4, 2, 3, 4, just to make some little hash marks here. So the first thing it says here is that f of x has a hole at x equals 1. So I have a hole at x equals 1. I have no idea what the y value is. They didn't tell me. But as long as I put it as x equals 1, it can be whatever I want it to be. Okay, so did that part. Then it says, as x approaches 4 from the left, f of x increases without bound. So what is happening at 4 on my graph? Vertical asymptote. If I approach a number and I'm going to increase without bound, there has to be an asymptote there. So at 4, I have a vertical asymptote. So then my function increases without bound as we get there. From the left. So did that. Then it says as x approaches 4 from the right, f decreases without bound. So I know it's going to have to look something like that. Right? At least that part of it is. Now that's all the information they gave us. We also should have a horizontal or slant asymptote somewhere. We don't know which one it would be, and we have no idea where it would be, but it will be helpful to us to draw something in. And since they didn't give me anything else, I mean, I can put it anywhere I want. So I can just put it here at y equals 0, because again, we don't have to go crazy. And then this would continue this way, and this would continue this way. And if I had turned you loose to do your own, yours may look different, but satisfy all this stuff. But I know if I actually turn you loose, most of you are just going to stare at your paper, paralyzed with fear, and so we're not going to do that, okay? Maybe we'll get to that at some point in this year. We good? Okay. So let's go ahead and do B. And let's see, this, we got a 3, make little 4 little hash marks again. All right. So g of x has holes at -2 and 3. Again, I know the x values, no clue what the y values are. So let's make one here at -2 or one at 3. And maybe they have the same y value. We don't know. Whatever, that's fine. I could have put it up here if I wanted to. As x approaches -1 from the left, so what's happening at -1? Vertical asymptote. So as x approaches -1 from the left, the function decreases. And as x approaches -1 from the right, yeah, it also decreases. So it looks something like that. And that's all we know, but we know there's more to it. Again, we could put our horizontal asymptote anywhere. Let's just put it at y equals 0. And we have something that looks like this. So what this would look like on an exam is you be given these words and then have 4 graphs that you would have to match up what's what, that sort of thing. Okay? Could you do it that way, that part? Yes. Okay. That's fine. I'm not going to freak you out about trying to then that's all you're going to focus on and not worry about anything else. What questions we got? Anything? Awesome.